Take a look at a jar of everyday peanut butter. Now picture a flawless, gleaming gemstone. The gap from pantry to jewelry store seems wide, yet scientists have successfully figured out a way to take this cheap sandwich spread and transform it into the hardest natural substance on Earth. It sounds like pure science fiction, but this is a highly documented, real-world scientific experiment. The true value of an object isn't defined by the shape it takes right now. It is dictated entirely by its hidden atomic ingredients. Despite its incredible monetary value and famously scratch-proof exterior, a diamond is almost entirely composed of a single, highly common element, carbon. This diagram shows the true elemental makeup of these items. Notice the identical C symbols. That is the exact same element making up the graphite inside your pencil, a dirty lump of coal, and the plant matter crushed up inside a spoonful of peanut butter. If carbon is so universally abundant across the planet, why aren't all these carbon-rich objects naturally turning into diamonds on their own? Having the right elemental ingredient is meaningless without the extreme environmental triggers required to force a physical transformation. To find those environmental triggers in nature, you have to travel about 150 kilometers straight down beneath the Earth's crust. Down in the mantle, you find the two missing ingredients: unimaginable planetary pressure and extreme heat, baking the carbon for millions of years. Under this brutal environment, loose, chaotic carbon atoms are squeezed so tightly together that they physically snap into a highly specific, unbreakable arrangement. This specific geometric lock is known as a diamond lattice. It is the sole reason the stone achieves its famous hardness. Nature's diamond factory relies on deep Earth geophysics and a massive amount of time. Researchers wanted to test if they could artificially recreate that crushing depth of the Earth's mantle inside a controlled laboratory. They chose peanut butter, completely ignoring its culinary properties. They just needed a convenient, highly carbon-dense biological sample. To do this, scientists placed the paste inside specialized scientific anvils. These are massive, highly calibrated presses that are designed to safely generate planetary-level pressure in a tiny, confined space. They cranked up the artificial pressure, forcing the carbon within the peanut butter to squeeze tightly until it underwent a massive structural shift. Scientific sensors definitively detected the formation of real diamond structures crystallizing within the crushed paste. Human engineering bypassed millions of years of geology, physically triggering carbon crystallization right on a countertop. Before you grab a vice grip and a jar of peanut butter, know that this process is physically impossible to replicate in a home kitchen or garage. This scale comparison shows the physical reality of the lab results. These are not gemstones. They are entirely microscopic, nearly invisible structures. These tiny creations hold absolutely zero commercial value. They are completely useless to the jewelry industry. The experiment is a triumph of atomic manipulation, not a get-rich-quick scheme for producing cheap gemstones. If these peanut butter diamonds have no commercial value, why do scientists invest massive resources in creating them? These extreme pressure tests allow researchers to simulate the inaccessible deep mantles of Earth and the hidden geology of distant exoplanets. Observing how carbon reacts under this duress provides astronomers and geologists with critical data they could never physically reach or observe in nature. An ordinary jar of peanut butter serves as a powerful, accessible tool for understanding planetary physics. So remember the atomic potential sitting in your pantry. If this science surprised you, drop a peanut and a diamond emoji in the comments below, and don't forget to subscribe. The universe constantly recycles its building blocks. Under the exact right pressure, the ordinary is mathematically capable of becoming extraordinary.